All right, chapter 10, lesson 4 is comparing populations. So we're going to look at two different types of graphing options today. One is called a box and whisker plot, and the other one is a double dot plot. So those terms, if we move on to the next slide, a double box plot consists of two box plots graphed on the same number line. I'm going to show you a picture of what that looks like. And then a double dot plot consists of dot plots. So every dot is representing a quantity of one, and then you can see the values that they're connected with. So we're going to look at both examples of these. I think the dot plot itself is just maybe a little bit easier to understand. Box plots are a little bit different, and I think this is the first time you've ever seen those. So this is kind of what a box plot looks like. So it gets this name because it forms a box in the middle. And I called it a box and whisker plot because it has these lines that stick out on each side and then end at a certain value. Well, what does all this mean? Well, every part of this has a certain portion to it. So one of the things that's going to be important is the median. The median is going to be a line down inside of this box, this rectangle. Notice here that our median is not in the middle of the box. It could be, it doesn't have to be. This is the median value of all your values that are present. It doesn't mean that it's going to be right in the middle. So think about this, for example. If you had a test and scores range from a 0% to 100%, it doesn't mean that the median value that someone scored is 50%. That is the median of those values, but the median value of the class that tested could be an 80%, which would be really good. Think about whenever I put averages on the board, the median is kind of that middle, is the middle of that. So the median doesn't have to be, right in the middle of all the values. So that's why we see this one kind of offset here. You'll also notice that this whisker is quite a bit smaller, which means that there are a lot more values that are located to the right of the median that are higher than the median. The whiskers extend out, and at the very end of the whiskers are the outliers. The outliers are the lowest and the highest values that are present. So back to my example of a test, the outliers would be 100% if someone scored 100%, and then 0% if someone got nothing right, which is not usually the case, right? We also have these terms quartiles, and this is a little bit tricky too. It says the data is divided up into 4 equal parts, and it's a little bit hard to see this, but, and I kind of have to move out of this, so hopefully you'll be able to see this okay. It's going to get a little bit small here. This is the only way I can annotate on this. But we have the median is right here, right? It's down the middle. And so if I know that, think of this as almost like a candy bar. The candy bar would end at over here on the right at the extremes. Those are those outliers. And then the candy bar would end on this side at the lowest values. So now I've got it split into 2 chunks. Notice how the median here is not right in the middle. But then we also have the first quartile and the third quartile, which means this chunks it into 4 sections. Notice how my lines are here. They're not equal sections because that is determined based on the number of values that you have in there. The more values that I have in a section, the larger that piece of the quartile is going to become. So this means by this one, you know that they're not equal here. That means that there must be more values that are located in this the fourth quartile here, the fourth section. There's more values that are present in that. So in the case of a test, as a teacher, this is what I want to see. I don't want to see a lot of scores down here in the low score range. I want to see more scores up here in the high score range. So the quartiles help us see that. And this often is really tricky for students to see that. And you can even find the interquartile range, which is the difference, the distance between the first quartile, so right here, and the third quartile. All right, so that's what it looks like for a box plot. And really, we're going to concentrate on the mean, the median, and the range for these terms. So here's the first question. So we see the double box plot representing the cost of MP3 players. And this is multiple choice. I kind of designed the notes to be multiple choice because that's what your homework's going to be. So it says MP3 players at two different stores compare the centers and variations of the two populations. So we have two things there. Centers is talking about the medians, the middle values. Remember what I said? That's that line that goes through the box. So that's what this first question deals with. Variations is dealing with the range, and we're going to deal with that in the next question here. So if I look, I see that Electronics World comes all the way down. There's this line, and that corresponds to this value of 70. So the median value at Electronics World for an MP3 player is $70. And if we look at Bargain Basement, if that is here, that is 60. So now we can see that Electronics World median price is 70, Bargain Basement is 60. So we should be able to make the conclusion that the median for Electronics World, that shouldn't say world, is greater. That's the one that's true. Median for Bargain Basement is greater is not true because it is lower. This was 70, this was 60. And you'll see that on the next slide, 70, 60. We cannot assume these medians are the same because they don't fit at the same value. So medians are much easier to see with box plots than they will be with the dot plots that you're going to see here in a bit. We'll deal with that in a little bit. So now we're going to move on to range. And now we're going to try to determine, so this is where we're trying to find the variation. So that's where I'm going to compare the extremes. The highest priced MP3 player at Electronics World is $100. The lowest priced MP3 player is where this ends down here. And mine is kind of blocking it, so I can't see it very well. It says that it is $50. So we've got $55. My screen has some stuff on it that you're probably not seeing, so I can't see it very well. So we got a $100 and we have $55. And then Bargain Basement, we have $80, and then we have $40. So that means we would need to subtract those. So 100 minus 55 gives me 45. And then 80 minus, did I say the wrong thing there? 80 minus 30 would be, this has got a mistake in it. So let me fix that real quick. This should say 80 minus 50, which would equal 30. Sorry, I should have looked over those first. So 80 minus 50, because that's where this one ends here. You should be able to see that. So if the range for the lowest price at Bargain Basement ends at 50, then the difference there between the highest and lowest cost is going to be $30, which means that Electronics World, I know it still says work here, this has the biggest span, the biggest range of prices. So if you're a person that was after, a variety of different costs for an MP3 player, if you wanted to really check out your options, Bargain Basement wouldn't be the best store to go to. Electronics World would be because they have more of a range of prices. So that's how we use the double box plot to find the median and the range. All right, so now we're going to look at a double box or a double dot plot. And here we're looking at the number of emails that Pedro and Anika have throughout a period of 16 days. So there's a couple of things that don't stand out as well. You can see the range about as easily, but you cannot see the median nearly as well here because the dot, it doesn't label it like a double box plot does. But we're going to start here with finding the range, the variations in the two populations. And I see another typo here. I misspelled Pedro's name. So we have to look at the lowest value and the highest value. So we see these are the number of emails they have. So on one day, Pedro has, on 4 consecutive days, he has 37 emails. And then on 4 days, he has 36 emails. And on 3 days, he has 35 emails, and you can kind of go down the progression. So we don't really need the highs and the lows here. We do. So we know 37 was the most emails he ever received, and then 32 was the least number of emails that he ever received. So he's got 37 to 32. So the difference between those two values is 5. With Anika, we see that she had one day where she received 38 emails, and then she also received lower values all the way down to 30. So 38 minus 30 would be 8. And so then we can assume that Anika has the greater range. She has the greatest variation in those two values when we subtract the highest and lowest. Again, the ranges are not the same because 5 and 8 are not the same value. So that's how we find the range. Probably the trickiest thing that you're going to have to do, aside from the mean, which I'm going to talk about here in a second, is determining the median from a double dot plot, because it's going to have to involve some counting here. And this is really kind of tricky to show you via technology, because what I like to do, if we were doing this in class and we had a paper in front of us, I would encourage you to put one pencil on the lowest value for Pedro and one pencil on the highest value for Pedro. You could also use your finger and then count in. So I can't really do this with my cursor, but I'm gonna show you one while I put my finger on the other one. So I have, although you can't see this, I have one finger on this value of 32. And so what I'm gonna do is I'm gonna count 1 and 1, and then now I need to count the other value for 32, and then I'm gonna move my cursor up here. So what I'm doing is I'm kind of moving in. Think about having your hands on two sides of a ruler. Those would be the extremes, right? The lowest value and the highest value. And then as you move your fingers together, you get closer to the median, the middle point of that ruler, if you move in at the same increment. So every time we're just going to move in 1. So I moved in 1 and 1, 1 and 1. Now I'm over here to 33, 1 and 1, 1 and 1. And then now I'm going to drop down here because I've already used up those 4. And use this one and this one. And then I keep just doing that. This is, like I said, is really hard to show you. And what we should end up seeing happen is that you're going to have these two values on the next slide left. And that's not very clear, but I wanted to kind of show you that there were, my fingers, when I moved them in, were left at this top dot and this dot right here, which means it has two values right next to each other that are the median. Those values were 35 and 36. So because there's not a clear median, I'd add those together and divide by 2. Well, that puts me at 35.5. So again, that's not one of the values he actually received. You can't receive a half email, but that is the middle value of all the values expressed for Pedro. Anika's are a little bit easier to see, but we do that same thing. We put our pencil here at 38, and then we also put a pencil here at 30, and we start counting in. So 1 on 1, 1 and 1, and you just kind of keep moving in there, and then you'll end up at this dot right here, which is a dot for 32. So the median value for Anika is 32. Again, think back to the double box plot. Remember how I said that your median isn't necessarily right in the middle? Look at all of these spread of values that are over here and how all these values are clustered. That means if we made a double box plot out of this, it would look similar to what we saw earlier, with a smaller rectangle over here and then a larger, longer rectangle that extends over here, because there's just more values that exist, or a longer range of values that exist over on this side. These values are very clustered. So we're able to determine the median here is 35.5 and 32. So we know that Pedro's median is greater. Now, the last thing I wanted to talk about, I didn't make a slide for this, is finding the mean. You're going to see that show up on the homework today for a double dot plot. So what you have to do here is you have to add up all of these values. So I would just start here at 37. And then I would take 37 plus 37 plus 37 plus 37 plus 36 plus 36. You have to add all those values up, and then we have a total of 16 values because it's 16 days. So we would divide that. We would get the average number of emails per day. So it's the same thing that we've done before. It's just representing that information in a different way. But knowing how to find the median, knowing how to find the range, and knowing how to find the mean are the things that are going to show up in this assignment. A little bit of tricky stuff. Remember, we'll have a Zoom for our classes that will be helpful to join, that will walk you through kind of the assignment. But that's how we use a double box plot and a double dot plot. Thanks for tuning in. One more lesson to go for this chapter. Thanks for watching.